Hey everyone, I'm Shah. In this video, I'm going to talk about how we can evaluate large language model applications. I'll start by discussing the limitations of the typical vibe check approach that most people use when building with LLMs. Then I'll review how we can do better than this through 3 types of evals. And finally, I'll walk through a concrete example of how I used evals to systematically improve a YouTube to blog conversion tool. So jumping right into it, typically when building any kind of application that involves a large language model, the first and most common way to check if the prompt that you're passing to your LLM is any good is by doing a so-called vibe check. Essentially, this is where you evaluate the performance of a prompt by skimming its corresponding outputs one example at a time. For instance, if I wanted GPT to write a YouTube title for me, I might start by asking it this prompt here: write me a YouTube title for a video on LLM evals. Then basically I would see if I could improve this prompt by skimming the output. So this is what GPT-4o Mini said: mastering LLM evaluations, key metrics, and best practices. This is kind of like a typical response you'll get from a large language model. For whatever reason, they love to start titles with like mastering or unlocking or something like that. Upon seeing this, I might go back to my prompt and add something like, don't start with vague words like unlocking or mastering. And then we see that it gets a little better. So it says how to effectively evaluate large language models, key metrics, and methods. So I would say this is a bit better, but it's a little long. Typically, you want your titles on YouTube to be short so people can actually read it when they're scrolling on the homepage or something like that. So upon seeing this, I might do yet another iteration where I add, make sure it's no longer than 65 characters, shorter is better. And then we get this title here: how to evaluate LLMs for real world applications. So this is a pretty decent title. It only took us like 3 prompts to get here. You can get pretty decent results through the vibe check just through a few simple iterations. Some of the pros of this is that it helps you move fast. It took me about 2 minutes to just iterate through a few examples and then finally arrive at a title that is decent. And this is a great way to go from 0 to 1. So a lot of times when you have an idea, there's a lot of benefit in just building an initial prototype of your system, just like as a baseline. And you'll typically just learn so much going through a single full iteration of the build. So it's kind of ironic. You actually will end up building your final product faster if you basically just build 2 versions of it, like an initial prototype that's just fast and dirty and it's supposed to be scrappy, and then the final version of it, as opposed to trying to get that final version in one shot. But of course, there are downsides to the vibe check. So one, it's kind of a pain if you're trying to compare multiple designs. Like for example, trying to compare multiple models, you're trying to compare different temperature choices, you're trying to compare different structures and formats for your prompt. Maybe you have a handful of different few shot examples that you want to incorporate in the prompt. Easily, all these different combinations is going to be overwhelming to just vibe check your way through. And ultimately, this leaves performance on the table. Since you're not able to explore so many different options and you're not systematically evaluating them with a clear metric, it's hard to really optimize the system. So this is the motivation of evals, which are simply numbers that correlate with the outcome you care about for your system. For example, let's say we have these 3 different prompt options and they all have a corresponding output from a particular model. Some metrics that might help me distinguish which prompts are better than others are things like the length. So here, I personally prefer shorter titles, specifically titles shorter than 65 characters, and maybe like 50 to 55 is the sweet spot. So I'm going to try to look for titles that are within that range. This is something you can just easily check. You just count the number of characters in each title. Another thing we might want to optimize for is the CTR, so the click-through rate of each of these titles. You could definitely do these various different live experiments from real human feedback. Alternatively, you could develop some kind of model that is trained on YouTube titles and a corresponding CTRs. And then you can try to have like an estimated CTR for each of these titles. But ultimately, CTR is something that we care about because, on YouTube, you want people to click on your videos and you want people to watch them, and they can only watch them if they click on them. So you want CTR to be high. Additionally, maybe there's an expert grade. As you spend more time on YouTube, you start to learn what titles work and what titles don't work. So maybe I can have some kind of YouTube title expert review these and tell me which titles are good, which titles are bad, based on some guidelines or framework that they've defined. But the key thing here is that each of these gives gives us a different view in the performance of these prompts, and it makes what was initially just like a vibe check into something that's quantifiable and thus something that's easy to improve. Clearly here, higher CTR is better. We want it to pass the expert grade, and we want the titles to be within that 50 to 55 sweet spot. So this is objectively the best prompt option of these three. So here I'm going to focus on three types of evals. Of course, this is not going to be a comprehensive overview. There's so much breadth to evals, and even within each of these types, there's so much depth. So there's realistically way too much for me to cover in a single video. But my goal here is to just give you like a flavor and a survey of some different ways that this can look to give you a basic idea. And then we'll make this a bit more concrete with a real world example near the end. The three types I'm going to talk about are code-based evals, human-based evals, and LLM-based evals. So starting with the code-based ones, these are simply rule-based assessments of a model's output. Often these are the easiest evals to both implement and interpret. For example, let's say you are working with some kind of closed-ended task, a task where there is a clear right answer. This might be something like having the LLM do math. The input question is, what is 2 plus 2? And there's a clear right answer, and the LLM says 4. We can simply just check if the right answer is in the LLM's response. So this is just something you can write with code. You don't need any kind of more sophisticated process for evaluating it. But of course, it was like a more difficult problem like this. The LLM might say something like this, and this is not the right answer. It's just off by 1 digit. So beyond math, other types of tasks that you can do these kinds of evals on are like coding challenges or logic puzzles. These types of tasks were famously used to train these modern advanced reasoning models like O1 and DeepSeek R1. So having this explicit, clear right answer makes it relatively easy to evaluate the model's output. Additionally, this is applicable to multiple choice questions, like something where there are a fixed number of options and the model has to pick one. So we can just compare the model's answer to the ground truth. But a lot of times the tasks that we want to do with large language models don't have a clear right answer, but we can still do this idea of doing these string checks or these regex checks of the output to help us distinguish bad responses from potentially good ones. So we already talked about checking the number of characters in YouTube titles. Another thing we could do is we could check if the first word in the title is like unlocking or mastering or understanding some suffix ending with ing. This is something we can simply check with a regular expression. And then checking the number of characters in a string is super simple. You just check the length of the Python string. Even though these are loosely correlated to good titles, they can still give us some insight on what system designs are better than others. So applying these to the three responses we saw earlier, we see that the first and the third one pass this first check of being less than 65 characters. And then we see that the last two ones pass this check of not starting with xing. So this agrees with our vibe check that this is the best title out of these three. Another thing we can use here are traditional NLP metrics. So these are things like the blue score and the rogue score, which have been around for a while and they're widely used. So the blue score is typically used for translation. Rogue score is typically used for summarization. These are just comparisons between two pieces of text to see how similar they are. So they're relatively easy to calculate. However, the obvious downside here is that, maybe we're not doing a translation task or we're not doing a summarization task. So these are quite limited. And even within these domains, they may not entirely correlate with the specific task that we're doing. So for example, we'll see later that I used rogue score in evaluating the performance of this video transcript to blog post conversion tool. And we'll see that the rogue score doesn't fully correlate with the thing we're trying to optimize for. Even though these code-based evals are going to be very use case specific, and a lot of times you're just going to write a custom function to do a specific check based on business logic or domain expertise for your specific problem. But hopefully these different examples gave you some ideas of what this might look like for you. The next type is human-based evals. So this involves using human judgment or behavior to assess the quality of an output. This is very much the gold standard, especially for a lot of open-ended tasks that involve taste, like writing YouTube titles or blog posts, or maybe require empathy, like some kind of AI doctor or AI therapist. These things are going to be difficult difficult to assess with code-based evals if it's even possible. That's where having these human-based evals is valuable. Here I'm going to talk about two general types of human evals. First type I'll call preference rankings. So this is basically, let's say you have prompt A, prompt B. You're going to pass them into an LLM. They're going to generate two responses. And basically what you have is a human expert, whether it's a domain expert or some kind of end user. You just have them say which of the two responses is better. This is exactly what OpenAI did when they created Instruct GPT, which was the model behind the initial version of ChatGPT. What they did there is they hired hundreds or even thousands of contractors to manually review responses from an LLM and grade which ones are better. So using these preference rankings, you can easily tell which of these two prompts is better. So basically you do this head-to-head comparison hundreds or even thousands of times, and then you can just see which of the two prompts or system designs is preferred most often. But a downside here is that using these preference rankings, you only get a relative sense of which prompt is better. It's not a big deal for prompt A versus prompt B, but if you had like prompt A versus B versus C versus D and so on and so forth, like you had dozens of different options, you'd have to do many of these head-to-head comparisons, and then the analysis of that is going to get a little complicated because you can also have like A beats B, B beats C, but then C beats A because they're just preferred for different reasons, because there may be multiple dimensions that humans are evaluating these responses. So these preference rankings only give us a relative sense of performance, not a global or absolute sense. For that, we can take a different approach and use a expert grader. So here, instead of comparing two prompts and responses head to head, we can just have a single prompt, pass it to the LLM, get a single response, and then have an expert evaluator sit down and give the response a pass-fail score based on some guidelines, and then explicitly write out their reasoning. This is a process that's described in reference number 4, which is a really nice blog post by Hamal Hussein, who has a lot of experience deploying real-world LLM systems for his clients. So the upside here is that now you have a global sense of the response's quality. You don't need to do a head-to-head comparison to see if one prompt is better than another. This simplifies the analysis, like if you have dozens or hundreds of different prompt and system design options. But perhaps most importantly, what happens during this process inevitably is that the human expert, the evaluator, is forced to explicitly define what is a good response and what is not a good response. This turns out to be very much an iterative process where more responses make the evaluator realize that their guidelines need to be updated and made more clear, but then eventually the guidelines become solid, and then you have a pretty good system for evaluating these responses. Although human-based evals are super flexible and they can evaluate basically any aspect of a LLM system, the clear downside is that this isn't very scalable. It's very time-consuming for someone to sit down and review responses and give them grades. It's a little faster to do this head-to-head comparison, but still takes time and attention, which is why a lot of times in practice, humans are only a part of the evaluation pipeline. The real goal of getting this human evaluation, whether it's preference rankings or an expert grader, is that they're used to enable LLM-based evals. So basically, an LLM-based eval is using an LLM instead of a human to evaluate the output quality of a model. And so we can go back to the same two approaches as before. We have this preference ranking approach and this expert grader approach, but instead of having a human do this, we just replace that with an LLM judge. So this approach is also called LLM as a judge, and this gives us the flexibility of human-based evals while also making that process very scalable. So for an expert human, grading 50 responses might take a few hours. In that same time, an LLM judge could evaluate 100 or 1,000 times as many responses. But a key step here, which is not trivial, is to align the LLM's judgments to human preferences, to the human evaluators. A lot of times this in of itself becomes like a whole project and undertaking because there are a few problems with the LLM judges, as we'll talk about in the case study in the next slide. But one of them is that LLMs might prefer responses from themselves, essentially. So GPT-4o might prefer GPT-4o responses to Claude responses, even if the human judgment preferred Claude in that instance. So a lot of work goes into getting the LLM to actually agree with humans. This is typically just done through prompt engineering, so iteratively updating the prompt until you have decent alignment, like 90% overlap, or you could also train a model to do this or fine-tune a model to do this. Training a model is what OpenAI did when they created Instruct GPT. So they created this reward model, which basically simulated human preferences, and then they were able to use that to do reinforcement learning with human feedback and ultimately make Instruct GPT. And if you don't know what that means, I talked about it in a previous video, which I'll link here. So to make this all more concrete, let's walk through a example. A few months ago, I shipped this product web app called Y2B, which converts YouTube videos into blog posts. And so even though this is something that I personally get value from because I built the system and I know what to expect, and it's easy for me to edit blogs just because I've written so many at this point and I know what I want and what I'm looking for. Some feedback I got from a kind user, genuinely kind, because most users don't give you feedback, so you don't know if what you built is any good. So genuinely kind. And they said that it didn't get me close enough to how I wanted to write the article for it to be worth it. It would have been easier for me to just start from scratch. So this is a great example of vibe checks not leading to optimal performance. So I used vibe checks to write the prompt for this tool here, which resulted in it working most of the time for me. But on the first try for this user, it didn't work, which means that there's probably not going to be a second try. So if a user tries your product for the first time and it doesn't give them a good outcome, they're probably not going to try it a second time unless you kind of do some additional messaging and say, hey, I updated the product, would love to get your feedback a second time, and then maybe they're going to try it again. So I saw this as a great opportunity to try to systematically improve the prompt that I used to do these conversions using Evals. And so my process is listed here. So first I curated a set of baseline blogs and YouTube videos. Maybe you've noticed that all my YouTube videos have a corresponding blog post. So I actually have a lot of data that I can use to evaluate this kind of system. I can just take all my YouTube videos and extract their transcripts and generate blogs for them, and then compare those AI generated blogs to the actual ones that I wrote myself. So the first step of this process is just curating the set of baseline blogs and YouTube videos. Next, I extracted the transcript from each of the videos in this baseline. Step 3 is that I wrote an initial prompt, a starting point, to generate blogs from the transcripts. Step 4 was the alignment process. So I aligned the LLM Judge to my preferences, which was basically preferring the human generated blogs to the AI generated ones in this head-to-head comparison. And then step 5 was to iterate on the prompt I wrote in step 3 to systematically improve it based on the win rate against the human generated blogs. So I'm going to walk through each of these steps, and additionally all the code I used here is freely available at this GitHub repo shown here and linked in the description. Step 1, curating the baseline blogs. What I did here is I picked out my top 30 blogs according to earnings on Medium. I'm just using earnings as a proxy for blog quality. And the reason that might be a good metric is that the earnings are based on not just the number of views that the blog gets, but how much time people spend reading the article. So it's kind of a more holistic, a more robust measure compared to just looking at views or reads alone. So I just manually copy pasted all the titles of my top 30 blogs by earnings. And then Medium allows you to download all your posts on the platform. They'll just email it to you in a zip file. So I downloaded that zip file. And then finally, I had Claude write me some code to pick out the top 30 blogs from this massive extract and to convert them into Markdown. So the final result are these 30 blog posts. These random characters here are actually the video ID corresponding to that blog post, and .md is just for Markdown. The next step is, now that we have the baseline blogs, the next thing I'm going to do is extract the YouTube transcripts for each of them. So I also just manually copy pasted all 30 video IDs into a text file, and then I ran this Python script here, and it just read each line of this text file, and then used the YouTube transcript API Python library to grab all the transcripts and write them each to a separate text file. Final result of that is now we have 30 transcripts saved in my code base. Now that we have the human generated blogs and the corresponding video transcripts, now we can use the transcript to create a AI generated blog. And so I had Claude write me a prompt for GPT-4o Mini. So this is the first part of it. It wouldn't all fit on one page, but the full prompt template is on GitHub, and I also shared in the blog post for this video. But basically, I just take this initial prompt. I didn't really spend much time optimizing it. I just wanted a starting point, and I used that to generate 30 blogs based on the transcript. So these are now saved in a separate folder, but they have the same names as the human-generated blogs. So now step 4 is probably where I spent most of the time on this project. Here I'm going to use an LLM Judge to evaluate the quality of the AI-generated blogs. But before I can do that, I need to make sure the LLM Judge is actually aligned with my personal preferences. So to test that, what I did is I took a real blog and then a corresponding AI-generated blog, and then I passed that into the prompt template for the LLM Judge. So this is a different prompt than the one used to generate the blogs. This prompt is used to evaluate which of 2 input blog posts is better. Here we're using that preference ranking approach. So a key point here is that you're going to need to iterate on this LLM Judge prompt until it aligns with human judgment. So the quote unquote correct way to do this would be for me to manually read all 30 real blogs and all 30 AI generated blogs, and for me to define a ranking. But that would be very time consuming and probably unnecessary, because I can confidently say that I'm going to prefer the real blogs that I personally wrote to these initial AI generated blogs. So basically the human eval data in this case is just going to always prefer the real blog to the AI generated one. After like 3 or 4 iterations for this LLM Judge, I was able to get this LLM Judge to prefer the real blog 92% of the time. But another caveat here, which is quite interesting, is that there's a phenomenon with these LLM Judges when you're having to do preference ranking called position bias. Basically, when I did this, the LLM Judge was always preferring option number 1, which at first, if I wasn't careful, would make it seem like, oh, the prompt template is working great, let's move on to the next step. But what I did once I saw that really good performance is I switched the order. So instead of putting the real blog in option 1 and the AI one in option 2, I flipped it, and then I saw the preference ranking stayed the same. So basically, it still preferred option 1 to option 2, even though option 1 were now the AI generated blogs. This is something that seems to happen a lot, and they talk about it in references 3 and 6. 3 is a review paper on evals, 6 is a YouTube lecture about them. So to mitigate this, I actually ended up doing 2 things. First, the final version of the prompt explicitly instructed the model to evaluate the blogs separately and to compute some kind of score for them. This reduced this position bias, but it didn't eliminate it. So I also just ran the eval both ways. I did it one way where the real blog was in position A, and then for the second run, the real blog was in position 2, and these were 2 different numbers. So the win rate for the real blog was different depending on whether it was in position 1 or position 2. But then what I did is I just averaged these 2 win rates together to get the final evaluation metric. But eventually I got the LLM Judge to a good enough point, so I moved on to step 5, which is where I used the LLM Judge to guide updates to the blog generation prompt to improve these AI generated blog posts. The final prompt looks like this. This is a prompt for GPT-4o Mini, while the Judge LLM is GPT-4o. And so here I did 4 iterations, and the results of that are shown here. So this column is the iteration number for the prompt. This column here is showing the win rate against the human baseline. With each new prompt, I generated 30 AI generated blogs, and then I compared those AI generated blogs head to head to the corresponding real ones that I personally wrote. And then I used the win rate of the AI generated blogs against the real ones as the eval metric. So we can see for the first prompt, the AI generated blogs only won 8% of the time in this head-to-head comparison, but then that jumped up to 13% of the time on the second iteration, and then went up even more to 23% on the third iteration. So we can see that the prompt's getting better and better, but then it drops down in iteration number 4, and here I just made some like manual tweaks to the prompt based on how, at least I think, think I personally write blogs, but that led to a significant decrease in performance, which is kind of interesting. But also for comparison, I computed the Rogue L F1 score for each of these AI generated blogs. The Rogue score basically computes the similarity between a reference text and a target text. So in this case, the reference text are the YouTube video transcripts and the target text are the AI generated blogs. And the Rogue L score is basically a measure of similarity between the two. So this is an NLP metric, a code-based eval. We can see that it actually tracks with this human win rate. So it's getting better and better until prompt number 4, where even though the Rogue score goes up, the win rate plummets. This might be telling us that the Rogue score doesn't fully correlate with what we ultimately want to optimize for. Or, of course, it could be telling us that the win rate sucks and we should listen to the Rogue score. So this was my first pass at this. I'm sure there's a lot of opportunities for improvement. So if you have any suggestions, let me know in the comments. Okay, well, let's talk about what's next. So this was my first time playing around with LLM evals. I was very much a vibe checker for the past 2 years, but now I'm becoming more systematic. You may have noticed that I didn't use any frameworks or libraries to do these evals. I just wrote everything from scratch, and that's generally my approach for a lot of this stuff because it's going to be so use case specific and so custom that a lot of times the existing tools just may not be able to do specifically what you want to do when it comes to evals, and then you're going to have to write custom code anyway. So basically the startup cost of learning a new tool or framework isn't usually worth it for me, so I tend to delay learning new tools and libraries. But a couple of them have come up a few times, which has made me more curious and made me actually consider learning about them and making videos about them. So the first one is OpenAI. They just put out a beta for their evals platform, which looks pretty nice. So I can do a video on this if people are curious. Also, Linksmith seems to have a pretty nice interface for doing evals. So I could also do a video on Linksmith if there's interest, or if you guys have any eval frameworks or libraries that you love and they don't have this issue that I'm saying, that they're too rigid and don't allow you to do custom things, let me know. I'm new to this stuff, so I'm ignorant. Just let me know what you guys have found works for you, and I'll be happy to take a look at it. And then finally, there is a blog, of course, for this video. And even though this is a member-only story, you can access it completely for free using the friend link in the description below. And with that, as always, thank you so much for your time, and thanks for watching.